Now let's take a look at an example of a definitive screening design that Chris did and was published in a JUMP journal. It's a catapult example, typical of what 3M does with their training of people using design experiments. In this particular case, the catapult has 6 controls: band tension, which is continuous, and they use 3 levels. The stop number, which is a continuous, and they use 3 levels. Cup placement, which is continuous with 3 levels. Band attachment on the arm is continuous with 3 levels. Number of books, 0, 1, or 2, that were stacked underneath the front edge of the catapult, so it affects the angle. And we treat that as continuous for 3 levels. And then the 6th factor was a 2-level categorical factor. It was the ball type, where they used a golf ball and a ping pong ball. Pretty dissimilar items. So here's the article that Chris published in a JUMP magazine, and down on the bottom is a layout of the design. And so we've got tension, stop, cup, band attach, books, ball, standard order, and then there's the results. So the circled runs show that each 3-level factor is run 6 times at its middle level. And the actual 4 factors were coded 1, 2, and 3, and negative distances resulted when the ball fell behind our 0 mark. Here's the second page of the article, and there's the students up in the right-hand corner. And here's the output. We'll come back to this later as I demonstrate to you how Minitab will both create this experiment and analyze it. I'll now demonstrate how we can use the DSD application in Minitab to reproduce Chris Noxheim's catapult experiment that he performed in Antwerp with Peter Goose. First thing I will do is go up to the Stat menu, down to the DOE menu, and you see a DSD design menu item. So I'll click that. Up comes a dialog box. Chris used 5 continuous factors. He used 1 categorical factor. He used 2 center points. He did not use any blocking, but if you wanted to use blocking, you would just add the number of blocks. And if you wanted to have the blocks, instead of being 1, 2, 3, 4 in numerical order, just have them the order randomized, you would click that. But I am not going to use blocks because Chris did not. I do want to look at it in standard order. Down in the dialog box, you'll see that there's information about some of the properties of DSDs. So number 1, they're minimum runs, which is good for screening. The main effects are free from 2-factor interactions. 2-factor interactions are not confounded with each other. Quadratic effects are free from main effects, and quadratic effects are free from the 2-factor terms. And response surface models are possible if some of the effects are not active. Now I can click the Show Code button, and the information is replaced with the code for the macro. If I click OK, that macro code is automatically copied to the clipboard. And one of the workarounds we have to use is we have to load that into the dialog command line editor. And to do that, we hit the Control L and then Control V to paste, and then click Submit Commands, and the DSD design is created. Notice there are 5 categorical factors, X1 through X5, and 1 categorical factor, C1. There are 16 runs. I'm going to fill in, replace the names of the X1s and the categorical with the factor names that Chris used, and I'll be back shortly. As you can see, I've changed the names of the factors to the names that Chris used in his experiment, and I've added the distance factor. Now we will want to analyze, so we have to go up to Stat, Regression, go to the middle regression, and over to Fit Regression Model. For response, we want to add distance. For continuous predictors, we're going to go tension, stop, cup, band attach, and books. Select those. In the categorical factors, we're going to use the ball, which was the ping pong ball, PP, and a golf ball. Now we're going to go down to the model button, and we're going to select all the predictors. And terms through order 2, I'm going to click Add, and that adds all the interactions and all the two-factor. I'm going to click OK. I'm going to click the Options button, but there's really nothing here at this point. There's some box transformations and weights you could add. I'm going to cancel that. I'm going to go in on the coding, and when we have categorical factors, we need to use the -0 + 1. Click OK. Then the real secret to analyzing the experiment is the stepwise, and we're going to use forward selection. And the default I'm going to leave, and it's not going to work so well, and I'll show you why. But we'll leave the 0.25, and then we'll click OK, and click OK. And that was pretty good. I'm going to enlarge the session window, and the best place to look is in the terms, and these terms do not match exactly the values that Chris got, and it's because we use the alpha of 0.25. The stepwise procedure just stopped a little bit short. So let's go back and do that again, and I can just edit the last dialog box. I'll go over to stepwise, and this time I'm going to put in a 0.05, and then click OK, and OK again. And this time we get the exact numbers that Chris got. We got 25.9 for tension, 29.4 for stop, 9.3 for the band attach, books -17.7, and -37.58 for the books interaction, the book square, the quadratic term. So we can see that this DSD not only provides quadratic terms, but it has some interaction terms, the tension and band attach interaction. Now I'll show you how we can optimize the catapult system by going up to Stat, Regression, the second regression command, and slide it over and go all the way down to the response. The default value is do not optimize, but we want to set the optimizer to maximize the distance. So we can just go OK, and we get an optimization plot, which is an interactive value, and we can see that we get the same value that Chris got, 175. He got ±10. We get something a little bit different on a confidence intervals. Let's look at the interactive value. We can see that we want tension at its maximum value. We want the stop at the maximum value. We want the band attach at its maximum value, but we want books someplace in between. And the golf ball is here, and it's the ping pong ball. So let's see what happens if I slide this over to the golf ball. You can see the value here in red is what the current value is. And so with a golf ball, I'm surprised we get 151. And let's say we wanted to use the minimum number of books. We're down to 129. Let's say we just only used the low tension. We're down to 50. Well, that's pretty much it for the optimizer and the DSD application. It will create a design from 4 to 20 continuous factors and from 0 to 5 categorical factors, including blocking. So this is Mike Mercer for Mercer Quality Consulting. Thanks again for watching. this video on what I think is really one of the most exciting developments in designed experiments in a long time. And we will be able to analyze them using Minitab version 17. 3M's probably still got version 16. Barbara Ryan, who I suspect is of Irish descent, released Minitab 17 on St. Patrick's Day, March 17th. So enjoy and get the new version of 17. It's got a lot of new features. Thanks again. Mike Mercer signing off.